Hey everyone, this is lesson 525, solving and applying quadratic equations. This lesson is really focused on summarizing what we've been doing for the last few lessons. I will give you some problems to practice here more so than teach you anything new. Hopefully I'll share with you some of my thought process on choosing really which method to use when solving quadratic equations. So some reminders of what you should already know. Our standard form, like I've mentioned before, making sure you understand what a quadratic equation looks like. Make sure you understand what the A, B, and C represent and how to find those in an equation. And then knowing that this is a quadratic equation because it's also set equal to 0. All right, so if we have an equation given to us in this form, at that point you would have to decide which of the three approaches should we select when we're going to solve this equation. So the three that we've gone over so far is factoring. So factoring would be our example of maybe using the box, and the x is something we've been using for factoring. And the whole goal is really to end up using zero product property. So factoring is really the first step, and then the goal is to get to use a zero product property, which is usually means we have something factored and we get to split it up into two separate things. And I'll give you an example of that in a second. The second is completing the square, which is really that's something new that was introduced in this chapter. And when we complete the square, we're really thinking of the visual of an actual square with algebra tiles. And if we could figure out what to add to both sides, then we could change the form from standard form into a perfect square form. Once it's in that form, then it becomes a lot easier to solve. You're going to be square rooting both sides of the equation. So that's the reason why we like to use completing the square, because the algebraic steps are a lot shorter. But not everything can be factored. So sometimes things do not factor nicely, or they cannot be factored. And then completing the square technically always works, but sometimes the equation given to us is not the easiest numbers, and we might need to modify the equation. So sometimes that might not be an option. So when those two aren't options for us, then quadratic formula will always work. So sometimes people prefer the formula because they know it's going to give you the answer. They could just plug in numbers and solve. The problem here is it's quite large, and sometimes if the numbers are kind of big, it might get intimidating, and the number of steps you have to do might be a lot more than actually factoring or completing the square. So some people will do this all day long, even when factoring would be like 3 or 4 steps. Quadratic formula is going to be could be double amount of steps. So make sure you know how to do all 3 of these, because when you have to select, it's nice to have options. All right, so I'm going to give you some examples of all 3 of those. As a reminder, these are all worked out already, so most of this is just you copying down examples in one place, so you have a good set of notes to reference. So the first one is factoring, so we could do our zero product property. So in this example, I have x squared minus 7x plus 10 equals 0. This is what we're trying to solve. As you notice, I have my area model. I filled in the pieces. I also have my x, and I filled in all that stuff. I'm not going to go over and review how to factor. If you need to reminder of that, then I would suggest going back and rewatching the lesson on that. Let me know if you need me to tell you exactly which video that is, or maybe you already have that in your notes. So the goal is to do your area model and use the X so that we could figure out the insides, right? Because those are the insides. Then we're going to take the outside of the area model, and that's going to be our factors. So this is the part where we actually get to use the zero product property. So zero product property says we could split it up into two separate equations. Once you do, in this case I'm adding 5 to both sides, or I'm adding 2 to both sides, and it gives me my answer. All right, so that's just as a reminder, again, copy that down just so you have a good simple example of what I expect from you. If I ask you to factor to solve, this would be an example of some work I would expect to see. All right, the second is completing the square, and that's our goal is to get into perfect square form. So in this one, we have x squared minus 8x plus 7 equals to 0. We're trying to solve this. Now, you may or may not be able to factor this, but when the directions say to use completing the square, then you want to try to use that method. If I don't specify which method to use, I say go ahead and solve it whatever is easier for you, then you get to choose. So I think this one actually does factor nicely, but for some people, maybe you're not good at factoring, and maybe you realize this isn't too hard when we want to complete the square. So I'm going to subtract 7 from both sides, really just so I could get it out of the way, that 7. And then I'm looking at this negative 8 to determine what the number is to add to both sides. So remember, this is where we talked about that negative b over 2 squared, right? Negative b over 2 squared. So that means we are trying to we're going to have a negative 8, or negative 8 squared, divided by 2, and all that squared. So that's what we're trying to do. So negative times negative is positive 8. 8 divided by 2 is 4. So this is really 4 squared, which is 16. So that's why I have a 16 here. And so once we do that, our goal is to simplify. Refactor. It's a perfect square, just like we created. Negative 7 plus 16 is 9. Square root both sides. Now this is perfect square form. So perfect square form. And so to solve this, we square root both sides. Don't forget the plus or minus in front of that square root when you solve that. And so when we reduce this, the square root and that squared go away. And if the square root is over a perfect square like 9, then you could always simplify it. So square root of 9 is 3. If you're not sure, use a calculator. You would just put square root of 9. You don't have to put plus or minus square root of 9, and that'll give you that 3. So if it was a square root of 16, that would be 4. Square root of 25, that would be 5. Square root of 36 would be 6. So make sure you understand your square roots, your perfect squares, and how to simplify those. All right, and so we end up with our two solutions, right? 4 plus 3 is 7, and 4 minus 3 is 1. So make sure you understand those two possible answers. All right, so those are, completing the square was new for us this chapter. Quadratic formula was also new. That was one of the latest stuff we just went over on the last lesson. And so as a reminder, here is the formula that we're actually using, right? X equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so make sure you have that formula. If you don't have it memorized, always have it near you, so that way whenever you need it, it's handy. All right, so we have 8x squared plus 10x plus 3 equals to 0. Our first step is really to figure out what our ABCs are. In this case, a equals to 8, right? That's the number in front of x squared. B equals to 10, that's the number in front of x. And c equals to 3. All right, so make sure you don't include x's in here. Sometimes people put 8x squared or 8x or 10x. That's not correct. All right, so be careful there. Only the coefficients. We're going to plug all those numbers into the formula, right? Reminder and strong suggestion is to keep the parentheses. Add parentheses here. I can almost guarantee you're going to get more problems correct when you include them than when you don't. So I've rewatched the last lesson on quadratic formula as I explained the reason for that a little bit more. All right, and then we always start with the inside of the square root, which actually has a name. It's called discriminant. But for the most part, it's a good place to start, and we start to simplify that early. But it doesn't hurt to do some simple things as well. So like 2 times 8, 16, that's easy enough to rewrite. So try to focus on the simple calculations first. You'll notice it does reduce nicely to a perfect square, so that's awesome. And we're left with 2 answers. The positive version of it, where we have a plus 2 and a minus 2. So negative 10 plus 2 over 16 is negative 1/2, and negative 10 minus 2 is negative 12 over 16, which is negative 3/4. So this works out to nice numbers also. No square roots in your answers. So this is a good solid example that gives you nice answers. All right, so we've gone over all 3 of these. So I'm just going to scroll up real quick. Zero product property, completing the square, factoring using zero product property, completing the square using perfect square form, and then quadratic formula. All right, so those are the 3 methods you need to be familiar with at this point. Something where you should be close to mastering. All right, so what this lesson's focused on is really, let's practice it. Let's see if you can use any of those methods. There's a total of 6 problems here. I'll just show you all 6 of them. Which method is best to use? So can you look at these problems and say, okay, I'm probably going to factor, I'm probably going to use quadratic formula. You don't want to say I'm going to factor all of them because they don't all factor. You don't want to say I want to do quadratic formula on all of them because that's a lot of work. All right, so we want to choose what's the easiest. So I'm going to give you the solutions to all these. I'm not going to work these out for you, but if you want solutions, or if you want an example of the work, or you want me to check your work, then let me know. I can look at your work and give you feedback. But for the most part, I'm going to show you the answers in a second. But if you want to work these out, if you're going to copy these down and you don't want to see the answers yet, then I would say definitely pause the video and then once you're done working out these problems, then you could see the answers that I'm going to show you on the next screen. And then I'm going to give you my suggestions on which method you could have used to solve this. All right. So if you're pausing, this is the time. If you're not, then let's move on. All right. So I'll start with the first 4. All right. So the first one, the first thing that I'll talk about my thought process on how to solve this or which method to select. So the first thing I do is I look at this expression and I notice there is no number in front, right? There's no a value in front of the x squared. So that instantly tells me it gives me the hope that I could factor this easily. So I do look at the number 27 and I try to think of factors of 27. And so in my head, I'm thinking, oh, 9 times 3 is 27. And then I add the numbers 9 plus 3, right? 9 times 3 is 27. And I notice 9 plus 3 equals to 12, which is that number. So in my head, I'm kind of doing what we normally do with the x. So once I think it's possible, I'm not quite working it all out in my head, but I'm thinking, well, that's pretty, it might factor, the numbers seem to be right, so then I might choose factoring. If the other thing that I notice is this 12 is a nice even number, and anytime there's a nice even number for your b value, when your b value is a nice number like 12, then that tells me completing the square will work nicely as well. So then I don't have to think about factoring, I don't have to think about area model or the x. I could just start doing completing the square because really all we need to know is the b value. All right, so those are probably be my 2 options. Both of them would work fine. I probably wouldn't use quadratic formula, even though it would work perfectly fine. I feel like the other 2 options would be a bit less work. So I don't want to do more work than I need to. All right, for the second one, this would also be an example of, if you didn't notice, this is a difference of squares. So this is a difference of squares. And so we did go over difference of squares before, which means the reason why we would need to know that is for factoring. So that would help us factor a lot faster, knowing it's a difference of squares. So that's why I chose factoring. 4 is a perfect square, 101 is a perfect square, and it's a difference. So that's kind of a big hint to use factoring. The other option would be completing the square, which might not be so obvious, but the basics of it is really just you could solve for x. Since there's only one x here, you could just add 121 to both sides, divide by 4, and then square root both sides. So that might be an approach to take as well, but for the most part, it's kind of the same thing as factoring. Quadratic formula wouldn't be difficult, really, but because there's a term missing, sometimes people get confused on what to do with the formula. So I would probably focus on either factoring or completing the square on that one. All right, and then for C, it's already factored for us. So it's not even in standard form, it's in factored form. So it doesn't make any sense to do anything else besides factoring. So this is already ready to solve. You could set each of these equal to 0, 2x minus 1 equals to 0, and solve. So the factoring has already been done for you, You just have to use zero product property. So that one is factoring is a must because it's already done for you. It wouldn't make any sense. You would have to multiply this out and then do completing the square. You're doing double the work. And same thing with quadratic formula. For D, you'll notice it's not even in standard form. Probably the first thing I would do for D would be to rewrite this. So this would end up being x squared minus 8x plus 16 equals to 0. So you'd have to rewrite it in standard form first for you to make a decision on what method to use. So factoring could work here as well. That might factor nicely. Also, I notice it's an even number. 8 is a nice even number for your b value, so completing the square could work as well. So it's a 1 in front, which is perfect for completing the square, and that helps with factoring. Again, quadratic formula would work, but I think it still would be more work than the other two. And then the last two, I'll zoom into this one. So for E, same thing, it needs to be rewritten. So I would probably rewrite this as 36x squared minus 60x plus 25 equals to 0. So there's a lot of big numbers here. Most people would be intimidated by this. One thing that I do notice is 36 is a perfect square, 25 is a perfect square. There's actually a special name for this. Is a perfect square trinomial, but most people don't necessarily remember those. But because they're perfect squares, these two, that would encourage me to maybe try to factor this. So I would probably try to factor it, even though they're big numbers. This 36 tells me I'm not going to use completing the square. It's not going to work. It's just too much. It's going to be too complicated for us right now. Quadratic formula would be a good option if you don't mind working with big numbers. So since they are big numbers, some people kind of don't want to use quadratic formula, but it might be the only option. As you could see, the answer comes out nicely. So I would probably encourage you to use either factoring or quadratic formula when trying to solve this one. All right, and then the last one again has big numbers. I would probably have to rewrite this one as well. And this one would be negative 32x minus 45 equals to 0. All right, so moving everything to one side, setting it equal to 0, it has to be in standard form or else you can't decide. And once you have it in this form, I notice 20 is not a perfect square, 45 is not. So nothing is telling me to maybe factor this. It might factor nicely. I don't know, but I don't want to think about it. It seems like my head's going to hurt trying to think about what numbers might work. The 20 tells me not to do completing the square. If it's not a 1, I don't want to do completing the square unless I really have to. And then quadratic formula is really our only option. And so that would be the method to choose here. Big numbers, but it's going to be still a lot easier than having to use these other methods. You'll notice the answers are decimals, which tells me that's a smart choice. Factoring, completing the square are not going to work nicely. All right, so not impossible. So all 3 methods would work on all 6 of these, but you have to decide, is it really worth the pain and agony or not? So I highlighted the ones that I would recommend using. I've given you the answers here so you could check your work. Try to do these. I wouldn't be surprised if one of these problems ends up turning up a test. An individual test, your final exam. So that's kind of a big hint for you. All right, so I'll leave you with that. Even though I've given you answers, I haven't shown you any of the work because you should know how to do factoring. You should know how to do completing a square. You should know quadratic formula at this point. So let me know if you need help with this, or if you're having trouble getting these answers, which is very common. Let me know so I can help you with that. All right. I think that's it for this video. And then the next lesson, we're going to be stepping it up a notch and trying to use a little bit more of our imagination. All right, see you next time.